It takes Nyan between 15 and 40 minutes to get to school each day, depending on traffic conditions. Nyan leaves home for school at 8 a.m. each school day. Let the random variable x be the time in minutes after 8 a.m. that Nyan arrives at school. The probability density function of x is shown below. What is the name of this type of distribution? Well, the common term is, we call it the rectangular distribution, but the proper name for this is the continuous uniform distribution. Now we're asked to determine the values of P, Q, and K. We're told it takes between 15 and 40 minutes to get to school. So that suggests to me that P is equal to 15 because here is the earliest arrival time. Q is going to be 40, latest arrival time. And then the width of the box from 15 to 40 is 25. We know the area of the box has to be 1, so that tells us that K is 1 over 25. We're then asked for the expected value of x, or the mean of the distribution. Now, for the rectangular distribution, just use the symmetry. It's right in the middle. So therefore, it is going to be 15 plus 40 divided by 2. So that's 55 divided by 2, which is 27.5. So the expectation of x is 27.5. We then want the probability that Nyan arrives at school before 8:25. So let's go back to our rectangle. And we know that this is 15, and this is 40, and we discussed the fact the width of the box is 25. So 8:25 would be here, and we want this probability. We can see the width of that is 10, and so quite simply, the probability of x being less than 25 is going to be 10 divided by the entire width, or you could do that as 10 times 1 over 25 because we know that that would be the area of that rectangle since the height of the rectangle is 1 over 25. And of course, both of those divide by 5, so we could cancel that down to 2/5. We now have some more information. We're told that Nyan will be late for her first class if she arrives at school after 8:28. Otherwise, she will not be late. If Nyan is not late for her first class, so that's a given, so we're being given that x is less than 28. What is the probability that she arrives after 8:25? So it's the probability of x being more than 25, given that x is less than 28. Which is the probability of x being between 25 and 28 divided by the probability of x being less than 28. So if we have a quick look at the distribution, So if 28 is here, then we know that this is 13 over 25. We draw the distribution again and just consider going between 25 and 28. The width of that is 3, so that's 3 over 25. So this one is going to be 3 over 25 divided by 13 over 25. 25's cancel, and it's 3 out of 13. If Nyan only wants to be late for her first class 4% of the time, what time should she leave home, assuming the 15 to 40 minute travel time remains the same? Well, 4% is 4 out of 100, which is 1 over 25. If we relate that to our rectangular distribution, where we know the height is 1 over 25, that means this little bit here, where this is essentially 39 minutes. So the 39 minutes of travel time needs to equate to being 8:28, which is when the first class starts. So what we're going to need to do is take 39 minutes from 8:28. So to get to 8 o'clock, I've just simply taken off 28 minutes. I still have another 11 minutes to take off, so that would put us at 7:49 a.m.